Okay, let's get started. Hello everyone. Good to see you guys again. We're Team DGEM, a team of Dusop, Jared, Andy, and Matthew. Before we start the presentation, even though COVID-19 gives us hard time, we want to give you a big hand for your efforts to pursue your goals and finish it one more quarter again. Today we are going to show you the final version of our sensational item. Like the famous saying in the slide, we've learned important 3 lessons from the first try. The product should be not only useful but creative to attract people's interest and end up with the purchase. Also, it is the best to invent new items, which is easy to use in daily life. We assessed that the first presentation in the logo contest was a great turning point for us to improve our project to much better item. In order to create the initial concept of the project, we narrowed down the common subject as to design a useful and fun tools related to food. And then we had brainstorming without any limitations to generate as many ideas as we can. There are some interesting productions in the slides, as you can see. The final decision was a cooking multi-tool like you can see in the picture on the left side. During the decision-making process, we had another discussion about what product will be the final concept among many creative ideas. So we made a few metrics to narrow down the top 5 ideas and evaluated each item. Using few metrics really helped us to make the logical and reasonable decision. The idea about multi-tool was motivated by 2 stories. That the first one is one of my friends always had a difficulty in flipping heavy or large and wide food on the frying pan like omelets, pancakes with a normal spatula. From this, we thought about the changeable size of the spatula. The second one is that sometimes moms or chefs need to cook many dishes at the same time, which make them hectic. So interchangeable handle that have multiple tools in one row saves space and help users not to waste time finding tools they need. That's how we were able to come up with the concept of multi-tool. Before we jump into the real CAD design, we made some requirements for our item. The spatula functioning part should be expandable to have wide surface mode, which is operated by a certain mechanism, and the rod needs to be designed to attach other cooking tools. Also, to make the tool washable, it should be assembled with some other parts. Lastly, we named the tool as multi-tool.
We performed research on Amazon for similar products in the market. We weren't able to find products that have had the exact same functionality, which is what we were hoping for as it shows uniqueness of our product. The very left image is a foldable grill utensil set, which is mainly used for outside barbecue. The one on the right is the indoor utensil sets. However, the products were just different utensils sold as a set. They're different from ours because ours can be used with one handle, which will save the storage space. When looking for just spatulas, the products that showed up were just one plain spatula as the bottom left image. There wasn't any spatula that had the same functionality as ours, with expanding and contracting. For a pancake spatula, the following example is found. However, this kind of spatula is only applicable to making pancakes. We want our spatula to be used not only on pancakes, but also on small items that require normal spatulas.
Going into this project, there were a lot of ideas that had to be realized. Our main design goals were to create utensils that saved space by using an interchangeable handle. We decided to make 2 tools. One was a spatula that had the ability to change its size, and one was a spoon with holes in it. Additionally, caps were created to protect the threads on the handle when they're not in use. Our design consisted of distinct sections: the handle, the 2 caps, the slotted spoons, and the spatula, which was the most complicated part by far. This figure shows the parts making up the spatula in an exploded state. We have the upper spatula head, the spatula shaft, the middle spatula head, the lower spatula head, the slider, the linkages, the keyway spacer, and the nut. Part 3 is the handle, and Part 10 is the handle top, but these were designed after the first printing cycle. Now we will discuss the functionality of each part. The shaft is 30 mm in diameter and 150 mm in length. It has a long keyway running through the center where the slider and the keyway spacer sit. The top end of the shaft has a female thread where the handle screws into it. On the opposite end, there are two pins that are press fit into the upper spatula head. As for the spatula itself, the profile of all three spatula heads are the same. They are about 80 millimeters wide and 100 millimeters long. The upper spatula has a lofted feature that connects to the shaft with two holes on the top. The lower spatula head has a 10 millimeter long pin at its center with an M5 thread on top. This pin goes through holes in the two other spatula heads and they rotate around it. All three spatula heads stay together by a nut that threads onto the pin on the bottom spatula head, which can be removed, allowing for the separation of the spatula heads for cleaning. The expansion of the spatula is accomplished by a set of two identical 4-bar linkages. The slider fits into the keyway in the spatula shaft and slides up and down. The slider is connected to a ball and socket joint on the linkage, which is a long cylinder with two sockets at the end. The opposite side of the linkage connects to the spatula heads, again with a ball and socket joint. The spatula heads rotate around the center pin. Overall, this system causes the spatula to expand to twice its size when the slider is moved down and to contract when the slider is moved up.
Now that we've had a chance to talk to you about the design process and the individual mechanisms developed during each print cycle, I'd like to take a moment to elaborate on the quality of those cycles. As we discussed in our last presentation, during the first print cycle we focused mainly on the fanning spatula of the multi-tooler. It was during this cycle that we printed the utensil shaft of the handle, the three spatula heads, the pin cap, and the slider with its linkages. However, we had to omit the keyway spacer, the handle plus its handle top, and a few additional tools that we've not catted yet. The quality of this print was pretty good, but we found that the link components were quite fragile. While we were very, very impressed with the quality of the threading. One other note that we had about the quality of this print cycle was that the press fits were a little bit snug, but this was fixable with carving.
Because of the general success of the first cycle, we decided to print our missing parts for the second cycle, which are the spoon, handle, and cap. The handle is 130 millimeters long and has a 30 millimeter maximum diameter, matching the diameter of the spatula shaft, but thins out to 18 millimeters, which makes the handle look more aesthetically pleasing and gives a better grip. On each end of the handle, there are two M16 male threads that connect to the utensil shafts and the caps. The slotted spoon was split in two parts. The spoon itself is 90 millimeters in diameter and 20 millimeters deep, and has an extruded section where two holes are located corresponding to the pins on the spoon shaft, which are pressed into the spoon to create a permanent bond. The shaft widens into a circle where a female M16 thread allows connection to the handle.
Moving on to the second print cycle, it was here that we focused on the handle and a couple of additional tools for the multi-tooler. During this cycle, we were able to print the remaining portion of the handle top, the hanger variant of the handle top, and a strainer spoon tool. However, we still chose to omit the keyway spacer, and we were unable to print some additional tools such as the iris mechanism due to integration troubles. The quality of this print cycle was slightly less exciting than the quality of our first print cycle, but still turned out quite well. We noticed again that there were a few fragility issues, but we think that this would be changed with something that will be mentioned in future works. And again, the threading printed quite well, but we noticed that the threading on one end was a little cumbersome. This time we had the opposite trouble with the press fits. We tried to reduce some of the press fit dimensions because of that snugness issue last time, but this time they were a little bit loose, so now we know that maybe carving just is the best option. I'll now let Andy actually kind of show you what I mean with some of these issues with the printing results.
These are the pictures of the final fabrication result. The overall results seem promising. When using the tool, we noted the spatula heads and the spoon were strong enough to lift objects such as a heavy wallet. The handle was the ideal size for gripping. However, there were slight detail problems with their design. The main problem of the design was the weakness of the ball and the socket joints that connects the link to the spatula heads, as they were too weak to perform the expansion mechanism we intended. Also, the slider wasn't as smooth as expected, which resulted in applying more force to move the slider, which then caused the ball socket joint to disconnect. When trying to use the slider mechanism, the ball socket joints came off and the spatula did not expand. Additionally, the press fit that connects the spoon to the handle was not strong enough, such that when held vertically, the spoon came off very easily. Also, one thread that connects the spoon with the handle was not as smooth as the thread that connects the handle to the body. When tightening the threads with a big force, the threads might break or bend. This is a video that shows the functionality of the product. In the first part of the video, the spatula is expanded during its use. The next part shows the spatula when it's contracted, and the last part is the use of the spoon. We conducted a survey to potential customers. 92.3% said they cook at least once a week. Only 56% felt comfortable using a 3D printed device to cook. 32% said they would daily use this device. 40% said weekly, 16% said monthly. 4% said they would use this occasionally for outside barbecue, and only 4% said they would still be hesitant to use the product. We gave out a range of prices they would pay for the product. The most popular price range was $10 to $15 with 46.2%. This seemed valid because when we conducted a research on existing products, we found out that the most of the spatulas on Amazon are around $9 to $14. With our product being more functional than existing products, we think that the price is very reasonable. Most of the apprehensions were the materials used for 3D printing. They were worried that the material would not be resistant to heat or if it's BPA free. Also, they had concerns about the vulnerability. They wondered if the spatula is strong enough to work well. Lastly, they had questions about the mechanism itself, but we think that this is caused from lack of explanation about the mechanism in our questionnaires. Last part of the questionnaire was to provide any comments about the product. They said if the spatula can rotate 360 degrees, it would make the product more appealing. They also talked about making the handle part more ergonomic, and they also talked about the product being more aesthetically pleasing. And lastly, some people said the product could be better if it was just one spatula head instead of the three. We conducted interviews with our parents since they are usually the ones that spend the most time cooking. We asked similar questions to the questionnaires. When they first saw the product, they were more skeptical than optimistic. They weren't sure if the product was strong enough to actually be used as a spatula. Another skepticism came from the angle between the handle and the spatula head. The angle might not allow the food to flip. They were also worried about cleaning the product after its use, as it might be a burden to detach the parts to clean. One of the improvements they suggested was having a button with a motor or a spring that will allow the food to flip automatically. However, they pointed out that cooking utensils should not be too complicated. We also introduced the idea of detaching the spatula head from another cooking utensil such as a spoon or an iris mechanism for pasta measurements, which they were satisfied with. They say they would buy this product depending on how many utensils were included.
Now that we've had a chance to show you the work that has gone into our project over the course of this last quarter, I'd like to take a moment to give a brief teamwork analysis, a little summary of how we functioned as a team. To break down the work distribution, we designed the device as a unit, but had individual team members complete separate mechanisms in SOLIDWORKS. Then, the teammate most experienced in SOLIDWORKS would edit these components, combine them into an assembly, and give us instruction on how he did so to improve and tips to improve our CAD skills. We found this to be timely, effective, and very conducive to learning. The report would then be broken down by parts CADed and willingness to take on extra slides or work. We felt that our team functioned very well together and was able to create a pride-worthy device despite having switched products early on. We worked together very democratically throughout this project, often using Q matrices to make design decisions. As we begin to draw this presentation to a close, let's discuss where this device could possibly go in the future, given the feedback we've already received throughout this process. We've discussed some of the possibility of additional tools as they become CADed, some of which were simply excluded for printing time constraints or integration issues, such as the scoop, pasta measurement, iris mechanism, and cake cutter tool. But we also felt that there are a few aesthetic improvements that could stand to be made. One of our group members, Jared, has made quite a few improvements to the sleekness of the device already, as will be shown in the next slide. In these design changes, you will also notice the inclusion of a new locking mechanism to replace the keyway spacer based on feedback we received from a classmate during our first presentation. In addition, we feel that there are some improvements that could be made to how we conduct our industry survey, as well as some additional finite element analysis to be conducted.
Given the feedback we received and the problems we faced with our print, we decided to make a few changes to our design. One of the major problems was that the ball and socket joints were not strong enough, therefore the diameters were all enlarged. Some of the feedback we took into account for the redesign were the overall aesthetics and ease of use. The design was modified to have a crescent-shaped cross-section with the size of 20 by 12 millimeters. This way, the handle is more ergonomic and looks better. To make the product easier to use, the threads on the handle were completely removed in place of a pin, which holds the handle on the utensil shafts. Finally, a pin is now used to lock the slider in place.
To end off our presentation, let's talk about some eventual goals for the multi-tooler. We believe that the perfect multi-tooler would have a metal composition, both to eliminate fragility issues without altering too many dimensions, and to eliminate the food safety concerns posed by the use of ABS. Our hope would be that this product could continually release new components for the multi-tooler's back end. This could be done through a subscription service or be bundled with existing cooking subscription services like Blue Apron. We would also want future prints to be done with a sleeker, altered design.